is an interesting problem if you're filling up water balloons. So a water balloon is like a sphere, and you want to know what is the rate of change, how quickly is the volume increasing with respect to the radius of the sphere when the radius is equal to 2 inches. So the first thing you need to know is the formula for the volume of a square is 4/3 pi r cubed. So I'm going to go to my difference quotient to figure out what is the formula for finding out the rate of change at any point in this equation. So I know that that is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Well, let's plug our formula into that. I want the limit as h approaches 0 of 4/3 pi x plus h cubed minus 4/3 pi x cubed, using x instead of r, all divided by h. Okay, let's do some work. I want the limit as h approaches 0 of 4/3 pi. Well, now I have to cube x plus h. So I'm going to take a little detour here for just a second. If I have a plus b, a binomial, and I'm cubing it, the formula for what that is going to equal is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, I would probably give you that if you needed to know it. But you could also just say this is equal to a plus b times a plus b times a plus b. So it's equal to, I'll use these two here first, a squared plus 2ab plus b squared times a plus b. And then just continuing to FOIL this out, I'm going to have a cubed. I'm going to do my a first, a times that, then times that, then times that, plus 2a squared b plus ab squared. Now I'm going to do my b's, plus a squared b plus 2ab squared plus b cubed. And combining like terms, I get a cubed. Now I have 2ab squared and 1ab squared. That's a squared b. And I have 1ab squared plus 2ab squared. That's 3ab squared plus b cubed. So how do we apply that to this problem? Well, I'm going to have 4/3 pi times x cubed plus 3x squared h plus 3x h squared plus h cubed minus 4/3 pi x cubed, all over h. So now I'm working with the limit as h approaches 0 of 4/3 pi x cubed plus, well, 4/3 pi times 3x squared h. So when I multiply my 4/3 pi times my 3x squared h, my 3's are going to cancel out. So I'm going to get plus 4, let's go 4 pi x squared h plus 4 pi x h squared plus 4/3 pi h cubed. So I took care of all of that right there. 1, 2, 3, 4 terms minus 4/3 pi x cubed. So all I'm really going to be able to cancel out right here is my 4/3 pi x cubed. Oh yes, don't forget, that's all over h. Let's factor out our h. Limit as h approaches 0 of h times 4 pi x squared plus 4 pi x h minus 4/3 pi h squared all over h. And so I have the limit as h approaches 0 of 4 pi x squared plus 4 pi x h minus 4/3 pi h squared. And as h approaches 0, this is going to go away, and that's going to go away. So I'm left with 4 pi x squared. Well, my original problem asked as the radius, which I used as x, is equal to 2 inches. So I'm going to plug 2 inches in here, and I'm going to get 4 pi 2 squared equals 16 pi. And I like to leave my answers in exact form, but the other thing I need to think about here is what are the units that I need to add to this. So my volume is in inches cubed, cubic inches, and my radius is just in straight up inches. So if my rate of change is 16 pi, I am changing 16 pi cubic inches for every inch of radius. So this is the answer. Don't forget the units. The units are going to require some thought. I know we're not used to working with them that deeply, but it is part of the problem because they're asking for what is the rate of change here. I have to be clear and specify my units.